Hi everyone, today I will be walking through my ESE 36000 project, the D&D Dice Reader. Some background knowledge about me. I'm a NETS 2024 student with some background in machine learning before taking the course. This class was really interesting to me because it taught me how to optimize code to run on edge devices, which was really new for me. So what's the problem that we want to solve here? Essentially, we want to train a model that takes in an image of multiple dice and it identifies the face-up values of the dice in that image. We want it to work for all D&D dice, all the way from D4, which are 4-sided die, to D20, which are 20-sided die. We also want it to work for different dice designs. Here is a demo of the model in action. In this demo, we will be showing the model running on 4 cherry-picked examples. 2 examples where the model works well, and 2 examples where it doesn't. This is an example of the model working relatively well. You can see that the model is able to successfully extract the dice in the image and classify all of them correctly. And this is another example of the model working well. You can see that it does a fairly good job isolating the dice faces and figuring out the face-up values. Here is an example of an image where it works relatively less well, with a lot of dice. So you can see here that it gets most of it right, but in some cases, it gets confused and assigns the wrong value to the dice. In this example, we can see the model extracting some dice from an out-of-distribution image with a textured background instead of a white background. You can see that it gets some right, but it gets most wrong. We have 2 models in the system. The first model, based on YOLOnet v3, performs image segmentation to extract the dice faces. The second model, based on MobileNet v2, classifies those dice faces into their respective integer values. In creating my segmentation model, I modified a Kaggle notebook originally meant for a competition counting the heads of wheat in an image. The biggest change that I had to make here was to reduce the number of filters in the CNN by a factor of 4, which essentially allowed the model to run on a phone. For MobileNet v2, I used a model pre-trained on ImageNet and added as much data augmentation as I could to account for the fact that our training set is relatively small for the task we're asking it to do. Finally, to deploy the system, I converted both models into the TensorflowJS format to allow it to be loaded by devices visiting my GitHub page. Note here that the model is going to run locally once the browser downloads the models. The performance of the model is relatively decent. The deployed model, when evaluated on dice not included in the training set, has an accuracy of 81.3%. This is pretty good considering that the dataset is relatively small.